So welcome to level 2 physics, voltage this time. So last lesson we looked at current, today we're going to look at voltage. So the learning objectives today are to explain the term potential difference. So we've already looked at this in static electricity, so it's kind of just going over that, and explain how potential difference behaves in series and parallel circuits. Okay, so let's look at potential difference again. So here you have an aeroplane flying over Heathrow. It has a initial gravitational potential energy, and of course a final gravitational potential energy as it begins its descent and into Heathrow. And the change in gravitational potential energy is a change in the potential energy, of course, because it's losing gravitational potential energy. And that we call the potential difference, because there's a difference in the gravitational potential energy. And the same thing, of course, can occur in electrical circuits. So in terms of potential difference in electrical circuits, you have an electron moving around a circuit. It has 1.5 volts or 1.5 joules per coulomb of charge as it moves around, goes through a light bulb, and now it has no joules because it's been converted from electrical energy into light and heat energy from the light bulb, and so it has lost its electrical potential energy. Okay, and this difference is called the potential difference, and also known as voltage in circuits. Okay, and there the electron continues on. Again, now it has no energy because it's given it all to it's all been transferred into the bulb, goes back into the battery, and then through a chemical reaction, it regains the energy per unit charge and back to 1.5 volts. So how do we record potential difference? We use something called a voltmeter. Okay? So a voltmeter is a meter that measures the voltage of any component in a circuit, be it the power supply, the battery, the light bulb, a diode. Okay? The important difference between that and an ammeter is that the voltmeter is connected across in parallel to the components which the voltage is being measured in, which we can see here. Okay. So how do we investigate potential difference? We're going to look at it in series and parallel. Okay, the first one we're looking at is in series and then in parallel. So in terms of potential difference, you can see it as an example is like doing racing or across hurdles. You start off with 100 joules. You jump across the hurdle, you lose some energy, goes to 80 joules, and then 60 joules, and finally to 40 joules. So the potential difference across these, you're going to lose 20 joules every time you jump across that hurdle. And I guess in terms of circuits, you consider the hurdle as being like a lamp. Every time the current goes through a lamp, it transfers the electrical energy into light energy and loses energy correspondingly. Okay, so the potential difference in these examples are all 20 joules. So in series, you can see that you start off with 100 joules, you end up with 40 joules. So it means that as the electron goes through, it has 1.5 volts to start off with, goes down to 1 volt. That 1 volt goes to 0.5 volts, and finally that 0.5 volt goes down to no volts. Okay, so it loses electrical energy each time it passes through a lamp. So you can clearly see that in a series circuit, the potential difference or voltage is going to be the sum of all the individual voltages. So if we have a circuit here with one bulb, a supply voltage of 1.5 volts, then the voltage across the component here, the lamp, will of course also be 1.5 volts. Makes it simple. Okay, and if we have 1.5 volts, then the supply voltage across these two are going to be shared, because obviously as the electron comes down, it's going to lose half its energy to the first bulb, or transfer half its energy to the first bulb, and transfer half its energy to the second bulb. So it's going to be 0.75 volts in the first one, and 0.75 volts in the second one. Okay, 1.5 volts and 1.5 volts, so that's going to combine to give 3 volts, and as you go through the two bulbs, it's going to again divide evenly, so that's going to be 1.5, let's get kind of used to that, 1.5 volts and 1.5, put a bit of dot there, 1.5 volts there. Okay, so it's shared evenly. And if you have 3 volts and 3 volts here, then it's going to be the sum of those two voltages is going to be the supply voltage, so it will be 6 volts. And if it's 4.5 and 9 volts here, then the difference between the two is going to be 9 volts minus 4.5 volts. So the voltage across the first bulb is going to be 1.5 volts. Moving along, we have 3 volts and 3 volts. They combine to give 6 volts, so it must mean that the potential difference here must be, you've got how many batteries? 1, 2, 3, so it must be 4 volts here, because we haven't considered the voltage of this cell here. And in terms of parallel, it's going to be the same for all of them, so it'll be 1.5 volts in that system, and again 1.5 volts in that system. Okay, here's a more complex circuit in terms of working out the voltages. Okay, so what I would do is I'd break it down into 2 steps. You have essentially 2 parallel circuits, but also those 2 parallel circuits contain a series circuit. So you can see that you've got 1 series circuit and 2 series circuit, but those 2 circuits are in parallel. Okay, so looking at this, gone from the previous slides, you can work out that the voltage stays the same between parallel circuits. So it means that this guy, the sum, has to equal 1.5 volts, and the sum of this one also has to equal 1.5 volts. So that means, because in a series circuit that voltage is shared, then you have to divide 1.5 volts by 2, because you've got 2 lamps. So it means that for every coulomb you get 1.5 joules per lamp, or 1.75 volts per lamp. Because 0.75 plus 0.75 equals 1.5 volts. And the same goes for this guy here, 0.75 volts per lamp. Okay, another really complicated one again. So this guy is going to be the same, 1.5 volts. And again, it's going to be in parallel, but it's also, these two are in series. So it must mean that that's 0.75, because they will add up to make a total of 1.5 volts in that branch. There we go. So to finish off, the something of a component is a measure of how much something is in the component. Okay. The potential difference. Okay, so potential Difference of a component is a measure of how much potential or energy is transferred in the component. Okay, that makes sense. Energy is transferred. My writing's a bit messy. The potential difference across the cell must equal the sum of the potential differences across the components in a series circuit. Okay, and finally, in a series circuit, current is equal or splits up. It's going to be equal. Current is equal, and potential difference is the splits up. Splits. Whereas in a parallel circuit, current splits down each branch, and potential difference is equal across each branch. And those are the two rules when it comes to parallel and series circuits in terms of current and PD/voltage in a circuit.